Again, welcome everyone. This is Dr. Samuela Guida from the International Water Association, and this is the kickoff of the PrimeWater Multi-User Panel Stakeholder Week. And today we will focus on water resource management. So some housekeeping rules while we have people coming in. So if possible, I'll ask you to please rename yourself, adding your name and your company. The meeting will be recorded for the minutes meeting. So if you have any concern about this, please let me know. There is my email address that you can contact me. If possible, we ask you to show your video according to your internet connection, but please mute your microphone where you're not speaking. For each presentation, we ask you to please add your questions in the chat box that you see just at the bottom. And if possible, indicate the speaker you are addressing. So for example, Samuela, and then the question. And just as a rule, after the meeting, you will receive the slide and the recording of the session. So that is with you. Perfect. So this is the PrimeWater Multi-User Panel Stakeholders Week. So what's the multi-user panel? So PrimeWater as a multi-user panel that serves as an international panel of users that provides expert feedback on Earth observation enabled services that are developed or extended in the context of the project. And the multi-user panel also participates in the co-generation process of PrimeWater through dialogue. So we had the first multi-user panel workshop at the end of last year, and we gather initial feedback on what different users think about different services that PrimeWater offers. And this second multi-user panel workshop, we organize it from today until Friday as a stakeholders week. And the stakeholders from different sectors are invited to around 2.5-hour session each day. And every day we will focus on a different sector. For example, today we are focusing on water resource management, and over the week we will focus on disaster risk management tomorrow, and then potable water and energy sector. And please note these are at a slightly different time. And then we'll finish Friday with amenity recreation and aquaculture. So the main objectives of this week are to provide you with an overview and an update on the services that PrimeWater can offer to the participants, and then understand how different sectors are using Earth observation services to address issues such as extreme hydrological events and harmful algal bloom. And then to discuss the added value of PrimeWater products when addressing those issues. So how can PrimeWater product help with when talking about extreme hydrological events or harmful algal blooms? So we have quite a packed agenda. Today's session is divided in three sessions. So we have a bit of an introduction, where Apostolos Tsimas and Evangelos Romas from the EMBIS, who is the coordinator of the PrimeWater, the organization who is the coordinator of the PrimeWater project, will present PrimeWater and PrimeWater products. Then after a little break, we will have presentations and a moderated discussion with our experts. And then we will have another partner of the project, BSB, presenting the user preference for Earth observation services survey that we have developed within PrimeWater. So we have prepared a little icebreaker poll for you, and I'll maybe stop sharing, and if you can quickly reply to this. So let's see if I can start this properly. So launch. So the first question that you should see on your screen is your sector. So if you can indicate your sector, consultancy, government organization, industry, NGO, regulator, university, or other. And then the second question is, do you use Earth observation technologies in your work? No, yes, directly, meaning you do use Earth observation, or indirectly use you take the data out of Earth observation. So as you see, the majority from you is from university, research institutes, then government organization. The majority of you does use directly Earth observation technology in your work. Thank you for that. And I think now I'll give the floor to Apostolis.
Great. Well, thank you again. Thank everybody that is joining this discussion about Earth observations and how Earth observation can support water quality hazards, exposure and vulnerability reduction. Well, this workshop is taking place as part of the PrimeWater initiative project. PrimeWater is a EU-funded project and is almost in the midway of its lifespan. Do you have access to just click on the next slide, Samuela?
You should be able to click on the presentation.
Right.
Yeah.
Okay. Great. Thank you for that. Well, water crises have been ranking the last 10 years the top 5 more important crises across the globe, and water quality has its role into that. So particularly harmful algae bloom outbreaks and risks they do have considerable impact across so many environmental, socio-economic domains. And PrimeWater is dealing with is about hub and freshwater, and how Earth observations can actually deliver reliable services to the water sector in order to address efficiently water quality, such water quality hazards, exposure and vulnerability. Although Earth observations have been used and are used in several integrated water resources management and climate change applications, the focus on PrimeWater is in operational small-scale applications, applications and workflows more close to the everyday, let's say, needs of the water sector. And this is why we value so much the feedback that comes from stakeholders from different water sector domains. We value so much of this interaction that we implement through those workshops. And of course, this is not just, it's just the beginning of the discussion. We welcome you also to join the group of on Earth observation technologies for water management that IWA has put together in order to maintain this an open dialogue around the possibilities of Earth observations in this domain, even after the lifetime of this project. Well, among the various possibilities that Earth observations can support in water resources management, the focus that we would choose to have in today's workshop is around forecasting services that are supported, that are powered by Earth observations. And this is a very quick overview how Earth observation, how PrimeWater, how, let's say, an operational forecasting system for water quality attributes has been put together within the context of PrimeWater, and how Earth observations can actually improve or make those services even more robust. So Very quickly, Earth observations in PrimeWater are used to improve the forecasting skill of complex hydrological modeling and forecasting services, either through a simulation methods within the models, but or directly with the machine learning algorithms, in order to be in the position at the end of the day to provide operationally forecasting products about different water quality attributes. Also, the focus here in terms of the time scale of the forecasts is on the medium, short to medium forecasting range. That means up more or less up to 10 days ahead of time. So, well, the next presentation, actually a demo video will be displayed, and trying to provide a quick overview of how certain services have been put together in operational mode for communication purposes, for demonstration purposes. And this demo will follow this presentation, and hopefully will stimulate the discussion further on. Okay, that's for PrimeWater. Going to the, let's say, topic of today's workshop that I would like to raise, and speaking about forecasting services, a big question for us is how this information can be actually be used in practical terms. Suppose we have, suppose we knew how a phytoplankton outbreak will evolve in 10 days in advance. Can this make a difference? Can this information have can have an actionable result that can improve the way that water sector professionals can deal with these threats? Of course, it's very difficult to have one response, one uniform response to this question, since different stakeholders experience in a different way the impacts from water quality outbreaks. And beyond that, they do have, and they do implement different practices within the context of their responsibilities. So we've just clustered these, well, these the possibilities for actionable response to have events in three, let's say, major families. Today, the emphasis, as Samuel has said, is going to be on the water resources manager and the perspective, and which is the perspective of those that are responsible, to discuss the perspective of those that are responsible for managing and acting on a lake level. So water authorities and bulk water managers might be key actors within this subgroup. When it comes to lake or reservoir management, certain practices obviously are in place. Different practices can be applied in order to address, to mitigate the impacts for water quality outbreaks, and more particularly HAB. And the potential that forecasts in water quality can bring is that actually can support proactive implementation of those services instead of being reactive. Also, it can support rational optimization, of existing practices in order to be more efficient in trying to mitigate the actual impacts out of these threats. It's always, well, most of the times it's much more, it's less expensive and more efficient to mitigate risks in a planned way, in a planned manner, well in advance instead of reacting to major systems failures. And this can be seen for this rough, let's say, compilation of costs around water disruption compared to practices that can be implemented beforehand and can be optimized, as I said, using forecasting and observation-enabled forecasts. So the rationale for being proactive when we're talking on a lake level is there, and hopefully these will. Our intention is to for these to be the central point around our discussion today. So, PrimeWater, behind PrimeWater, there's a beautiful team. Hopefully you will meet many of our members today and the following days. At that point, I'd like to thank you for attending this very, very quick presentation and let you enjoy the video demo that will follow. Thank you.
Thank you, Apostolis. I'll share the demo video now.
Hello, I'm Vangelis Romas from Envis, and I'm going to make a short presentation of PrimeWater's operational platform. The platform is available through a web browser, either through the PrimeWater's website or directly through the second link. This is the initial page of the platform with the 4 operational case studies of PrimeWater in Europe, United States and Australia. The PrimeWater currently offers 4 services, which are the EO-based monitoring system, the hydrological forecasting service, and the water quality forecasting service, which is offered both by process-based and data-driven models. I will now jump to Melbourne Western Water Treatment Plant, and I will start with the EO monitoring service, which provides operational EO-based water quality products from Landsat and Sentinel missions. On the map here, we are able to see the latest available satellite image for our case study, which is for today, obtained just a few hours ago. The product shown here is chlorophyll A concentration at a resolution of 10 by 10 square meters, and by clicking on the map, we can read chlorophyll concentration at various points of interest. You may notice a gap here in the center of the map, which, as you can see in the true color image, is due to the cloud coverage. Apart from chlorophyll A, we are also able to quantify turbidity, total suspended matter, total absorption, shaking disk depth, and also a harmful algae bloom indicator, which classifies the probability of HAB existence based on the presence of phycokianine pigments. Also, we are able to provide surface water temperature from Landsat. However, this product is not available in this case study due to the low resolution of Landsat at 30 by 30 square meters and the small size of the ponds, which causes a strong interference with the land boundary. However, surface water temperature is available on all the other case studies. In the calendar here, we can see the dates with available overpasses of satellites, and we can go back in time until 2015. Also, there is a useful tool for exploring the temporal variation of a parameter in a selected area. For example, in the graph here, we can see the historical turbidity values for the last 3 years at the selected point of interest. Currently, these EO-based water quality products are produced by EOMAP's processing algorithms. We also aspire to include algorithms from other remote sensing partners of PrimeWater, for example, CSIRO's processing algorithms. And we also aspire to include hyperspectral water quality products from Prisma and DESIS missions, although these products will not be available operationally, but only for historical periods. The next functionality of the platform is the hydrological forecasting service. I will now jump to Lake Hume and select the hydrology tab. This service is provided by SMHI and the worldwide HYPE model setup. In the map, we can see Lake Hume and all its upstream hydrological catchments. These two contribute directly in the lake, and if I click in one of them, I can view the hydrological forecast for 10 days ahead regarding river discharges entering the reservoir. In the graph here, we can see hintcast and forecasted values of river discharge for today and the following 10 days. Apart from river discharges, the hydrological model provides also forecasts of nutrients, nitrogen and phosphorus, and suspended sediments. And those variables are a very important input for the water quality modeling that is performed inside the reservoir. The hydrological model offers both a deterministic and probabilistic short-term forecast. If I switch to the probabilistic forecast, then we still have 10 days forecast, but this time we simulate a hydrological ensemble of 51 individual model trajectories, as you may see in the graph. So apart from the average ensemble value, we can have an estimation of possible range of values for each day, and we can calculate some useful statistics such as percentiles, which is a valuable input for quantifying and dealing with forecast uncertainty. There is also a third hydrological setup, which is available only in the European case study, which is a seasonal hydrological forecast, where we can have forecasts for up to 7 months ahead, averaged on a weekly basis. Moving further down to the modeling chain, we have reservoir water quality forecasting provided by Envis. This is the Mulargia reservoir in Sardinia, where we have used the Delft 3D suite to set up a three-dimensional hydrodynamic model coupled to an ecological model. The hydrodynamic model is forced with meteorological and hydrological input and provides us the circulation pattern inside the reservoir and water temperature for the next 7 days. The map currently displays water temperature for the top layer on a grid of 100 by 100 square meters and 20 vertical layers. By clicking on the map, we can read temperatures at each cell. We can also visualize the water velocities with these nice animated arrow traces, and of course I can move this time slider up to 7 days ahead in the future in 6 hours intervals. Actually, there is a nice tool that visualizes the evolution of the parameter in the forecasting period. For example, in the graph we are now observing the diurnal variation of temperature in the topmost layer. As I said, we are using a three-dimensional model, so apart from the top layer, we are also able to get information for any depth we would like. For example, here, in the middle layer of the reservoir, the temperature variation is not so pronounced. Values are almost identical for the forecasting period. The vertical profile of each forecasted parameter can also be viewed in a separate graph for any selected point. For example, here the model indicates that there is a thermal stratification at the selected point of the reservoir. The parameters of the water quality model include chlorophyll A, nutrients, phosphorus and nitrogen, suspended sediment and dissolved oxygen. Here I have selected chlorophyll A, and the map and the graphs are now showing chlorophyll concentration. And finally, there is a third tool that allows us to view cross-section of any simulated parameter along the two main directions of the reservoir. Both in the hydrodynamic and water quality models, we are incorporating data simulation techniques that are using satellite-based products as well as in situ measurements to correct the model state and avoid error accumulation. So with the process-based models, we are able to expand the available information that we have for our reservoirs up to 7 days ahead in the future. And compared to the Earth observation, we can also have information at deeper layers and information about non-optically active parameters like nutrients. Apart from the process-based models, Envis is also employing machine learning models for forecasting chlorophyll and algae bloom events. So I will now move to our last case study, which is Lake Harsa. Data-driven models are trained for specific areas of interest presented as triangles in the map using meteorological forcing, forecasted nutrient fluxes from the hydrological model, and are compared against EO-based chlorophyll values or even in situ measurements, since in Lake Harsa we had some nice historical time series with a large number of chlorophyll values and cyanobacteria cell counts, We are currently using three types of machine learning algorithms: Gaussian process regression, random forest, and random undersampling boosting. I will stay in the GPR model, which predicts chlorophyll A concentration only in the surface layer this time. By clicking on a point of interest, we are able to read the chlorophyll values at the current time step. Again, there is a graph that presents the time variation of the forecasted parameter. The dashed line are the hindcasted values, the continuous line are the chlorophyll values for today and the next 10 days ahead. One nice feature of the machine learning algorithms is that they can provide us with some confidence levels. So for an 80% confidence level, we can see that the predicted values of chlorophyll A concentration increase from 4 micrograms per liter to almost 20, and even higher for the 90% confidence interval. I will now jump to the random undersampling boosting algorithm to present you a different type of product we are using for bloom forecasting. So this algorithm has been trained to predict cyanobacteria cell counts, but not as a scalar quantity, but as a probability of exceedance of a specific threshold specified by WHO. And we have made this choice because we have seen that the model has a stronger skill in predicting if cyanobacteria concentration are going to be over or under the threshold of 100,000 cells per ml, rather than in quantifying exact values of cell densities. So in the graph, we can see that the model predicts that for the selected point of interest and the entire forecasting horizon of 10 days, we're having a no-hub situation with a high confidence level. While if I click to this point, then we see that we still have a no-hub situation, but this time with a lower model confidence.
Perfect. Thank you. Thank you, Evangelos, for that. I hope that was clear, and I will now like to open the floor for some questions, and I'll ask everyone to please switch on your video and your microphone if you want to ask a question.
Hello, good night. Can you hear me?
Yes, we can.
Hello, Apostolos and Evangelos. That was really good. And just to one question for Evangelos. Evangelos, can you hear me?
Yes.
Hi, Evangelos. When you talk about confidence, the level of confidence, is that based on a statistical model, or is that based on kind of model efficiency?
Actually, the confidence interval is available on the machine learning models. All these three different type of algorithms used are ensemble-based machine learning techniques. So we train a lot of models, a lot of different models, let's say 100 different machine learning models. And then based on the answers of each individual member, we can quantify the confidence level. So if all model members agree that there's going to be a no-hub situation, then we say that this answer has a high confidence from the model. While when model members disagree, then we can even we cannot, let's say, produce an outcome. And there's a third category also in the answers of the model that is unresolved. So if the majority of the members do not provide a clear answer, then we characterize this as a low confidence answer from our models.
Thank you very much.
All right. If no questions, we have scheduled a 5 minutes break. So I'll if that's okay for everyone, we can go grab a coffee quickly and then come back in 5 minutes. Okay, everyone. Thank you all. I hope you're all back. I ask, please, the speakers of this session, and Megan, you already your video on. Perfect. You can switch on your video. And so we are now moved to session 2. We will have experts presenting their experience on water resource management, and then a moderated discussion after the presentation. This session will be moderated by Megan Coffer from US EPA. So Megan, I'll give the floor to you to just introduce the speakers.
Thank you, Samuela. Hi, all. Welcome to the second session of day 1 of the PrimeWater Multi-Use Panel Stakeholders Week. We have 3 speakers for this session. Please post your questions in the chat box as you have them, and we will hold a single question and answer session at the end. First, we have Christophe Brachet from the International Network of Basin Organizations with a talk titled Spatial Altimetry and Applications in Pilot River Lake Basins.
Thank you, Megan. You hear me well? Okay. Hello, everybody. First, in a few seconds, with this first slide, I want to say that I made this slide with other colleagues, especially from the French National Space Studies Center, CNES, especially Alice Andral, and also colleagues from the French Development Research Institute, IRD, especially Stéphane Calment, Marielle Gosset, and Fabrice Papa, and other colleagues from the Congo River Basin Organization, Niger Basin Organization, and others. Thank you. You can give the first slide. So I will speak not only of quality, water quality, but also quantity, especially spatial altimetry and the SWAT program, and applications in river basins or lake basins in Africa and also Guiana. So the SWAT mission, as maybe some of you know, NASA, CNES, and other actors are launching a new satellite, maybe in 1 year now. It will be the first satellite mission dedicated to inland water. As you know, a lot of regarding spatial altimetry, a lot of other satellites were dedicated more to the sea and oceans water levels. So it will also make ocean, but especially surface water. So it is a launch with NASA and CNES and other actors, maybe in 1 year, if everything goes well. So it will give images of water level with a high vertical accuracy. We think that we can reach 10 centimeter of precision, vertical accuracy, and all the data and products will be of free access. So it will be the first global inventory of all terrestrial water bodies at a global storage change, and change in storage, and change also in river discharge. Slide. So I will first speak of applications in the Congo River Basin with a strengthening hydrological monitoring for climate change adaptation. It's a project funded by French Development Agency, AFD, and INBO is with the International Office for Water, is working with the Congo River Commission, which is named SICOS. Slide. So we have already begun this project a few years ago, and given provision of historical database on spatial altimetry. And the spatial data has been characterized with, compared with in situ data. The problem of the Congo River Basin is that you have very few in situ data. So we have tried, and we have already reached maybe something like 15 or 20 centimeters accuracy. And another challenge is to calculate the flow, the discharge from the altitude. So these works are ongoing. And we have also during this project put in the installation of several in situ stations to calibrate the spatial data. Slide. So the more important, of course, is not to have the data, the altitudes, but also to what applications can use this data. So we have already made several applications regarding hydropower, especially micro hydropower potential, and also applications to predict low flow for inland navigation in the Congo River Basin, which is very important in this basin as a transport way, inland navigation. And we have also installed with SICOS an hydrological information system, which is very interesting, as in the same system you have both in situ and spatial data in the same tool. So now we speak, we come again to water quality on the application where we go fast on the Lake Chad Basin with ERD and CNES and the Lake Chad Basin Commission, LCBC. Slide. So, sorry, it's in French, but it's a water quality monitoring regarding surface temperature, turbidity, suspension, and also other data, and also spatial altimetry. Slide. And we have a first result. I think this project, I'm not working myself on it, but it's ongoing with ERD and also UNESCO as other partners. Slide. So another application is on another very large river basin in Africa, the Niger River Basin, with the same partners, CNES, ERD, and French Development Agency for the funding. And we work with the Niger Basin Authority as a pilot basin for demonstrating the use of satellite products, not only spatial altimetry, but also other rainfall and rain discharge products, etc. Slide. We are working on this basin with first on the rainfall data, with a more precise rainfall in real time with GPM constellation. And also we have combined in what we call MGB in French, model Grand Bassin, so large basin model. We have combined this data to have results which are sometimes good, and we have tried to make predictions especially on the floods in the Niger River Basin, especially the town of Niamey in Niger country. The fourth application is in the Senegal River Basin, another basin in West Africa, project funded by a French Development Agency, which was called SCREEN, with the OMVS and the Senegal River Organization, and also the other the same actors. Slide. So this project is just beginning now. Maybe it will really begin in the early 2022. So in this SCREEN project, we have a lot of possible what we call virtual stations, and it's stationed with a spatial altimetry. And we have to decide with the Senegal River Basin Organization at which place we can put a spatial station, virtual stations, which can be useful for the different applications in the Senegal River basins. So we have some special application in these basins. Maybe, as you know, the Senegal River Basin country, OMVS countries, namely Senegal country, Mauritania, Mali and Guinea, which is the source of the Senegal River basin, have very large dams which are shared between the four countries. So it's very interesting to have applications on the management of those large dams. Slide. The last applications is we go out of Africa, if I can say, what we call in French a bioplateau. So it's the Guiana Shield. Slide. So we try, this project is ongoing. It has begun 3 years ago, and it's ongoing in a second phase now towards a transboundary observatory between Brazil, French Guiana, and Guiana Shield. And we have a particular hydrology. It looks a little like the Congo River Basin, as is a very large forest, as you know, and dense network. And so it's difficult. We can compare to the Congo River Basin. There's a very difficulties to access to in situ data, in situ hydrometric stations. So the altimetry and the use of, more generally, of satellite data, not only altimetry, is very useful in this context. So the two rivers are Maroni and Oyapock, which are concerned. Slide. Oh, yes. So we have very many applications regarding spatial altimetry, virtual stations, but also turbidity with watercolor and other spatial information, especially rainfall, which can be used to the several applications. So we have this project is ongoing. We have a mission which is just on the field now, and you can see on the map the different stations, virtual stations, which are studied in this project. So it was, as I said, Brazil, French Guiana, and Suriname, which are involved in this project. I think it's the last slide, but I just want to say, to finish, I think I have 1 minute, to say that what is very important in our work is to work with the different communities, because you have on one side what we can call the classical hydrologists with the in situ stations, and we have on the other side a new experts, especially from the research field, which it's not always easy to work together. And the other communities are the maybe engineering companies, which are building the applications downstream of the spatial data monitoring. And finally, maybe of course the more important are the final users. And as you have seen, we work with the different transboundary river basin organizations, especially in Africa. Thank you very much. 10 minutes.
Thank you, Christophe. We'll move to our second speaker, who is Stephanie Scollard-Ouz from NASA, with a talk titled Preparing for Upcoming Hyperspectral Missions, PACE and SBG.
Thanks, Megan. Can you hear me okay? Okay, great. So thanks for having me. And I'm going to talk, as Megan mentioned, about preparing for upcoming NASA missions. I'll give an overview of current status as well as some projects that we're doing to get ready for these upcoming hyperspectral missions. Trying to use my cursor. Okay, there we go. All right, so this is NASA's Earth observing fleet. Since a lot of people here use satellites, this is probably no surprise to anybody. Basically, the blue colored satellites are in extended operation, and then the green ones are currently operational, including the European partnership with Sentinel-6. So these are NASA and partner missions. We have missions in pre-formulation and formulation, and this is including upcoming hyperspectral missions. So we've got PACE, which is right here, and then we've got Glimmer, which will be an instrument on the International Space Station, and then EOS 1234 is the Earth observing system for missions, including SBG, which I'll talk about shortly. So PACE, launching first, will be around 2024, and this is NASA's investment in hyperspectral imagery combined with multi-angle polarimetry for atmospheric correction as well as characterization. The main instrument is the Ocean Color instrument. In the top image, you see an artist's rendition of it on the satellite. And it's going to have spectroscopy from UV and then 6 shortwave infrared bands for atmospheric correction, temporal resolution of 2 days, and a spatial resolution of about 1 kilometer. The 2 multi-angle polarimeters include HARP-2 and SPEX-1, and these are a combination of University of Maryland, Baltimore County, and then the Dutch for the SPEX-1. So these will help to characterize aerosols and clouds. Now, this slide was provided courtesy of Erin Urquhart. She leads the PACE applications program, and they have a very active program. They're already engaging early adopters as well as the science and applications team and pairing early adopters with scientists. So people doing basic research to get ready for PACE combined with early adopters are iterating on projects ranging from fisheries to sustainable aquaculture and oil slicks and other, as well as aerosol components as well. So the Earth System Observatory, as I mentioned, it's going to have 4 missions. They haven't been named yet, but they are basically to characterize these observables, one being surface biology and geology, and then another one being a combined aerosol clouds, convection and precipitation mission, a mass change mission for terrestrial water storage, and then surface deformation and change. So this is a look. In addition, there's part of the Earth observing fleet includes NISAR, which will launch in about a year. And then Glimmer and PACE are considered part of that future Earth observing system. And the goal of the Earth observing system is to integrate everything and to really take a Earth system science approach view of all of, from the ocean all the way up to the top of the atmosphere and land and everything, and just really combine all of the variables in interdisciplinary science of the Earth system. And so surface biology and geology will especially be, with its spectroscopy, will be geared toward vegetation type and physiology, as well as having applications in snow and minerals and agriculture and coastal applications. So SBG will have 2 main sensors. Light is the spectrometer, sorry. And it'll be wide swath and sun synchronous orbit in late morning with about a 16-day revisit. So it'll have much the spatial resolution and revisit characteristics of Landsat, but it'll be 5 nanometer bandwidth from 400 to over 1,000 nanometer, and then high signal to noise ratio. And a lot of the details are still being worked out with sensor tilt and how much data will be part of the coastal mask. Kevin Turpie is on this meeting and he's overseeing that activity. But that's, so it's in the pre-phase A, but so a lot of these details are still being worked out. And then SBG heat will be the other sensor, and that'll be on a different platform, but they will be with a early afternoon orbit, also sun synchronous, and that's in partnership with ASI, the Italians. So as part of SBG applications, I'm a co-lead of that group, along with Jeff Luval from NASA Marshall and Christine Lee from JPL. We did a community survey last year with a company called RTI, and we had over 560 unique respondents from 21 different communities. Several of you may have responded, and we thank you very much. But we were basically trying to assess the community value of this SBG mission for different applications. We focused on 4 different areas. We narrowed down from many areas to 4 different areas. And for this group, I'm just going to mention the algal bloom and water quality results. This shows the relative importance to the users of high spectral, spatial, or temporal resolution, and then coincidence, sensitivity, and latency. And primarily the latency is considered very useful for people if it's about 24 hours latency, and if it's matched with useful revisit rates. For early warning, people really want frequent revisits. But the 30-meter spatial resolution is also a high priority for users. And so we looked at our RTI, our experts at quantifying the economic value. They've had a number of very in-depth interviews with people, and they then quantified the opportunity zone of the highest being inland and coastal water quality for health monitoring. So SBG has high potential in that, and then aquaculture and farm siting and monitoring, with a slightly lower value for pollution or nutrient flow at boundaries and utility water intake, primarily because of being a surface sensor and space-based. So another thing we're doing with SBG is working closely with GLEON, the Global Lakes Ecological Observing Network. And this is a grassroots group. It's been an international group for about 20 years. And they connect researchers with, it's researchers who have research of different lakes and observing systems. And we are partnering with them to have Early Career Lake Expedition 2022. So it will be about 8 to 12 graduate students. At the moment, we're in the project formulation stage, but the idea is to hold 3 week-long workshops for training and collaboration, and to bring these early career graduate students along in the use of remote sensing for their lake research. We're going to be having 2 presentations at the fall AGU in December on some of the planned work that we're working on with them, and including some discussions with Copernicus. Copernicus has done water force, and that's been a very, Copernicus is generally very well equipped with applications and focused on societal value. And it's a relatively new focus for NASA. So it's great to collaborate and learn a lot from Copernicus on this. Also, the GLEON is doing an environmental data initiative. So this is the other thing that's going to be presented at AGU, where we're collaborating. So close to Goddard, we have the Chesapeake Bay. And for the past few years, we've had an interagency working group, including federal government, state government, and local, as well as academic institutions and NGOs. So it's an open group for anybody, any of the stakeholders in the region. And we focus on regional challenges that could be addressed with remote sensing. So we've been linking optical properties. We've been having a lot of effort to do field work together with our state agency partners. We have a new AeroNet ocean color site on a Coast Guard tower. This is for calibration and validation and improving the atmospheric correction in the bay. It's working, but it's not completely sorted out. The cables on it need to be adjusted, so it's not fully operational yet. But that's going to really help our atmospheric correction, particularly of some of these high resolution commercial satellite data sets that we're trying to use in the Chesapeake. So as I mentioned, we're doing field work with research, with resource managers and lab work at Goddard and University of Maryland. We're refining atmospheric correction techniques and developing spectral libraries. I have a postdoc who's working on phytoplankton classification algorithms. And we work, I'll mention, we work very closely with NOAA. They do the harmful algal bloom forecast, and anything that we develop, we're talking to them regularly, and we hope that they can adopt useful strategies and open science sharing of algorithms after they're developed and validated. We're also doing projects with USGS and other agencies characterizing marsh vegetation using optical and SAR satellite imagery. And we're hoping to start applying PRISMA to some of that work in preparation for future SBG. And I will just show, this is what Dirk Aron showed at the recent DESIS workshop. This is DESIS collected over the Chesapeake Bay compared to MODIS. And the top is, the top panel shows top of atmosphere uncorrected, and then the bottom panel shows corrected, and Dirk is using Acolyte for the atmospheric correction. So he's comparing MODIS and DESIS for the same area. And so that is, it still needs some work, but it's promising, and we're hopeful that the AeroNet site is going to help refine the atmospheric correction methods here. So in summary, we have many activities relevant to water resources management. We work very closely with Maryland and Virginia, the Department of Natural Resources, the Maryland Department of the Environment, as well as the Virginia Department of Health, in preparation for NASA's upcoming hyperspectral missions. If you're interested in getting involved with PACE applications, you can reach out to Eric Urquhart. And if you're interested in SBG applications, you can email me and I can add you to our list. That's all.
Thank you, Stephanie. We'll now move on to our last speaker for the session, Enrique Reis Dorfe from LACTEC in Brazil, with a talk titled Earth Observation for Water Management Use Cases in Brazil.
Thank you, Megan. Well, good morning, good afternoon, everyone. I'm Enrique. I'm a researcher at LACTEC and also the representative in Brazil for EOMAP. Samuela, I don't think.
Yeah, if you can use your arrow in the keyboard.
Yeah, it's not, all right. It's good. Yeah. So LACTEC is a leading Brazilian nonprofit organization. We have, it's an organization based on innovation. So we work on several fields of knowledge. We have a very vast experience, especially in the hydropower sector, and also a great expertise in water management, and a very multidisciplinary team. And today's presentation, I'm going to show you only a few cases, study cases where we used Earth observation data. And LACTEC has a partnership with EOMAP. If you don't know EOMAP, they are a world-leading company which works with Earth observation technology, and with this partnership we hope to expand the use of Earth observation in Brazil, since this is a very new topic here, and we see a very big potential in the country because, well, it's one of the biggest country that produces energy through hydropower. And so from our perspective, from which we had talks with clients, and from our point of view, the advantage of Earth observation is that the algorithms, they can be fully analytic, so you don't need to gather field data. Of course, having field data is good for calibration, but as an initial study, you shouldn't need that. This obviously the spatial and temporal coverage. So this is something you cannot see with traditional field monitoring. Is the spatial? You cannot like go back in the past, if I can say it like that. We have data since 1984 from Landsat, and we can analyze that data ever since then for the entire world. And also the spatial coverage, something that I like to emphasize a lot. on the right side here, there's this image that I like to show. Is that there's this measurement was done the same day for the satellite and the field measurement. So the field measurement station is a fixed station on the point. The result was 10 milligram per liter of chlorophyll concentration. But what we saw in the satellite is that 100 meters or so are from that field station, the concentration was up to 400 or plus. So this is something we see that Earth observation can help improve placing of field monitoring stations. And of course, it's a complementary thing. Here, so one of the applications of Earth observation, which was very prominent, LACTEC was hired by the Federal Public Ministry of Brazil to help assessment of the social and environmental damage caused by the Fundão disaster of 2015. You might have seen this on the news back in the time. So this was Brazil's worst environmental disaster. LACTEC did all the evaluation of the price and what happened in this disaster. And so it happened when structural failures on the dam burst and released 44 million tons of mining tailings. So those are the rejects of the mining companies in the area, and so that those tailings were discharged into the river. And through our assessment, we calculated that the disaster costs around $7 billion to repair. And where did Earth observation come in? So we used EOMAPS products to accompany the changes in water quality the whole area before and after the disaster. So we saw how much the water quality, mainly turbidity, changed before and after the disaster happened, and it was a very significant change. For example, areas where it was normal to have like 0 to 10 NTU of turbidity. The samples from the satellites was around 6,000 NTU, so there was no oxygen in the water, and that's a lot of dead fish because of that. We also used the water quality to evaluate the direction of sediment plume when they reach the ocean. This was done with hydrological modeling. So we saw basically where the tailings would go after they reached where they actually went when they reached the ocean. And this was helpful because there are some protected areas in the ocean, some coral reefs in the north, and they were worried that the contaminated sediments would reach there. And through modeling, we found out that no, the plumes, they went the other direction. Not that that is a good thing, but so it helped to see that. And there's also some lagoons in the coastal area of the river, and we use this to check if it's possible that the contaminated waters of the river can enter the lagoons during the flooding periods, which is very likely, as we saw. So we could tell that by looking at the turbidity products. Another application we had, this was done separately. This is a macrophyte monitoring. This might be interesting for some hydropower plants in Brazil as well. Through the combination of satellites and hydrological modeling and also water quality, we made an early alert system for the excessive growth of macrophytes in one reservoir in Brazil called the Jupiá Reservoir. So this reservoir had a small issue that one of like 10 to 20% of the reservoir was covered in submerged macrophytes, and this was obviously causing damage to the power plant. And we used this system to help with water quality parameters to help detection of the the rises in chlorophyll in the water, and also we could see the coverage, the spatial coverage of the microphytes using special spectral indices. And yeah, we use the water quality products as indicators of growth. So if there was a rise in water transparency, we would have an alert, so the transparency is rising. So we have to be careful, because then the macrophytes can grow more in this area, for example. And also other projects we're working with is the use hydropower suits project along with UMAP. So we have combinations of use solutions and hydrology for hydropower, mainly hydropower. And this is also something we are also explaining, the use of radar altimetry. So we also are very excited for SWOT vision, which Christoph mentioned earlier. And also the isoplastic project is something not related to water quality, but I also think it's relevant, because we are using, attempting to use Earth observation for plastic matter in the ocean. And we are doing a study case here in the Guanabara Bay in Rio de Janeiro. And I think that's it. Oh, yeah, to the future, we think that this is a very novel technology in Brazil. And so because of that, market visibility can be a little bit hard, because we're used to the traditional monitoring. I'm sure there might be not only for Brazil, but some other countries that as well. Yeah, but we believe in the potentials of Earth observation and seeing all the cases of success internationally and nationally. Yeah, that's it. So thank you very much for the opportunity.
Thank you, Enrique. We can go ahead and start question and answer. Again, if you have any questions, please put them in the chat, as well as the name of the speaker who the question is for. And while we're waiting, I had a question for Stephanie. What are the biggest challenges that you wish satellite data could help users to address, and what are the obstacles to making that happen?
Thanks, Megan. So yeah, the resource managers that we work with in the Chesapeake are challenged by shrinking budgets, and they have big areas to cover, and they generally only make it to their sampling sites once a month. So if anything happens in between, they don't know, and they really wish for satellite imagery to provide them sort of early warning of either harmful algal blooms or polluted runoff from land. Hypoxia is another concern in the Chesapeake Bay. So I would say the biggest challenge is we've got a lot of cloud cover. So the harmful algal bloom forecast that NOAA is currently putting out is they're working with that, but they would like to have higher spatial resolution, and they would like to have more frequent revisit so that they could see between clouds. One thing that I mentioned briefly in my talk that could also help is Glimmer. Glimmer is going to be geostationary, and that will have up to, I think, 3 or 4 looks a day at the east coast of the US. So.
Thank you. Let's see. For Enrique, what sensors, I noticed in your talk that you had mentioned Landsat. Are there other sensors that you're using besides Landsat? I was also curious about potential incorporation of commercial satellite platforms and what challenges you might have already faced or expect to face with including those.
Mm-hmm. On Landsat, we also use Sentinel-2 and 3, depending on the area. But we are very open to any satellites that we think that can be used both for water quality and water quantity. For commercial satellites, that's a big issue here in Brazil, because our currency is not the strongest. So every time we have to pay for example, commercial images like Spot, for example, the prices are very, very high. So usually we opt for Sentinel-2 or Landsat. So that's been usually pricing.
And then with those sensors, are you using just algorithms that your company has created, or are you using predefined algorithms as well for when you're doing these geophysical mappings?
No, we mostly use UMAPs. algorithms.
And then Christoph, I had a question for you as well. With the river levels that are constantly changing, I know that you have kind of balances with spatial and temporal resolutions. So what are some realistic temporal resolutions of these products? And if there's disaster response or a more localized use case, can that be adjusted?
Yes, thank you, Megan. Yes, it's a difficulty you mentioned. As you know, depending from the different satellites, we can have data maybe not more than every week or maybe 10 days and sometimes more, 15 or more days. So as you know, it's of course not useful for early warning system, especially early warning. So we try to make combination between this data and in situ data. And we try also, we work on very low, how can I say, floods, which go very slowly. If you take the Congo River Basin, you have several weeks, not to say months. If you take the case of the Niger River Basin in Niamey, the flood is generated in Guinea maybe 2 months before. I don't speak of the right tributaries, which can give also floods more rapidly. So it's a real problem for the flood warning. So we make a combination. We work also on the low, as I said, on the Congo River Basin for the inland navigation. We work also on the prediction for the low flow for navigation. So here it's very more useful. But as you mentioned, it can be a problem. We can also make combination between different satellites, and so with all that, we try to make products which are useful, but of course it's not useful for very fast floods. So it depends from the type of river and the type of flood.
Thank you. Stephanie, I just want to bring your attention. Somebody is asking for you to share the contact information in the chat. And then we have a question from Ulfa, again for Christoph. Do you overlap your results from Earth observations with in-field measurements?
I go? Yeah. Okay. Yes, as I said, we make a comparison between in situ measurements and satellite altimetry data. And as I said, we have very good results now, not with SWOT, because of course we work with other satellite like Sentinel, Jason, and others. And we already have results around 15 in the Congo River basins on two what we call virtual stations, which we compare to in situ station on the field station, and we have a very good results, like 20, maybe 15 centimeters sometimes. So we hope with the SWOT in more than 1 year, because after the launching of SWOT, we have to wait a few months, of course, to use the data, but we hope that we can reach 10 centimeters of accuracy.
Thank you. We probably have time for one more question. If anyone has anything else that they'd like to ask the speakers.
If not, we will keep monitoring the chat box during the session 3 of the workshop. So please feel free to add your questions there. Perfect. So we have another 5 minutes break. So once again, before we move to session 3, we can have this little break. I would like to thank Megan for moderating the session, and our speakers for providing their expert presentation. So we can go through a 5 minutes break once again. So it's 2:24 4, 5 here. So let's come back at 2:30. All right. I hope you're all back and refreshed. Thank you all for staying with us until session number 3. This session is called User Preference for Earth Observation Services. And I'll give the floor to Nikos, who will guide you through the survey, why we're doing it, and what's the main aim. So I hope you can see the presentation. I'll share my screen. And Nikos, over to you.
So thank you very much, Samuela. So one part of the project's endeavors is to learn from users' preferences and, if possible, to make an evaluation of these services in terms of how the user is valuing them, and specifically how the user is valuing specific characteristics of these services. So this is joint work with Lara Agnoli. This survey that you're going to help us collect data on is aimed at understanding barriers and preferences for satellite-derived water quality products. So I will be briefly reviewing what is our aim. We will start the survey, and also I will try to be guiding you on what kind of questions you will find in the survey, and in case I can motivate them, I will do so. So what is our aim? Our aim is to understand first the attitudes towards satellite-derived water quality products. The second aim is to find whether there are obstacles in adopting satellite-derived water quality products, and also to find the drivers in choosing satellite-derived water quality products. In that sense, we want to see if there are things which are specific to the products that may be blamed or responsible for adoption or non-adoption, and at the same time whether this applies to specific consumer types and user types and needs. So, so I would ask you to go to this link and start completing, please, this questionnaire until this following question, which says, how long have you been working for this business dash organization? Nearest number of full years, numbers only, no text, please. So go on completing until you find this question, you complete this question, and then I will come back and show you some less standard questions and how I would like you to think about them to respond.
So you'll find this link in the chat. I think Erin, yes, Erin has put this link in the chat. So if you click on the link, you'll see, maybe I can also share with you. You'll see this screen. Can you see my browser? Yeah, so just go down next and start completing until the question that Nikos was telling you about.
Once we have completed, I hope, the part of the questions which are rather standard for surveys, let's change totally the topic to show you what is our method in the following questions, which for us are key questions in this questionnaire. So we would like to know what are the drivers of your choice. And imagine, for example, that we're talking not for water, we're not talking about satellite observation services, but we're talking about wine. So you have these 4 wines, for example, 1, 2, 3, and 4, and you have to choose. So please take your phone or your computer and go to www.menti.com and use the code that you find on your screen.
Erin should also share a link in the chat to go directly to the survey.
Obviously, many of you don't know the wines, didn't have enough enough information. Now we have some people getting bottle 1 as well, and bottle 3. So we did that. We have done this with other subjects. And the results of the study for us is not just your choices, but the choice drivers. So this means that we, for example, can disentangle whether people have driven the choices were driven by back label information, by logos, by label style, and by price. So it's not only about your choices, but because the choices are organized in a specific way, our information analysis, our data analysis will provide us answers to what are your drivers. So the choices are to us more valuable than simply what you have chosen. So we can go to the next slide. So in this exact fashion, in this exact mode, we ask you to choose, for example, between 3 options, and these are the type of questions you will be asked to answer. So we give you 3 options of a water monitoring service: option 1, option 2, and option 3. The first characteristic that we give you is the image resolution. The second characteristic is the offered Earth observation-based water quality parameter. The third is the offered parameter representation. So all pixel values in the reservoir at native resolution, both for option 1 and 2, but then option 3 has aggregated reservoir statistics. For example, average value, minimum value, maximum. Offered frequency, so option 1 is 2-3 samples per week. Option 2 is 1 sample per week. 2-3 samples per week is option 3. And then they have also a price per sample. So we would ask you to choose one of these 3 services or none of them at all. And then this is the first level of information. I will go to the second, but this is about monitoring services. And the second type of question is forecasting services. So again, the format is the same: option 1, option 2, option 3 versus none of them. And here is the model parameter. So it's what you get from each one of those services forecasted. So is it heavy metals, priority substances, reservoir circulation pattern, etc. Then forecast horizon is sub-daily or 1 month ahead. And temporal and spatial resolution. So you have daily values at river level or at reservoir level. And then you have estimated price of forecasting services. And then you get the prices in euro or in US dollars. And again, you make your choices according to your preferences, to your needs, and then you can choose 1, 2, or 3, and none of them. Let's take again the wine example, please. So again, can you share the link?
Sure.
Okay, so you have another link now.
There is a common agreement that wine is sociable and fun. I'm happy about it.
Yes. And even majority think that is good for health. And and fewer people think that I should not drink wine.
I think there is a second question for this. No, sorry, there is not.
Okay, so we go back to the presentation. So this type of answers, So this type of answers will associate your behavior to the foundations of your attitudes and subjective norms, which will form your intention, and then the intention will explain the behavior. So it's not just the first glance results that we get. It's not just what you have chosen, but by your detailed answers, we are going to associate anonymously, of course, because it's not a matter of what each person has responded, but the statistical relations between what you have shown to be in terms of attitudes and norms, your intentions and your behavior. And this will help us associate specific aspects of these services with the value you give to them and how you also value them relative to other things, including the price. So, so you will find questions about familiarity, about trust, your attitudes, and even knowledge. And we understand, and this is exactly an important thing, there are no right and wrong answers. There is heterogeneity, and this heterogeneity is valuable to our study. So now please complete the survey and receive a 10% discount code to join the International Water Association. And thank you very much for your help. We really hope to have soon great results and share with the community and give you feedback on how much you have helped our project. So in any case, now by completing the survey, you have immensely helped our study to understand better how you value the products by their features.
Thank you so much, Nikos. And once again, please do complete the survey. And as Nikos was saying, that if you complete the survey, you will receive code to join the International Water Association that gives you a discount on 10% on membership as a thank you gift for completing the survey. So do keep that window open and do complete it until the end. Thank you so much. And Erin has just put the link again to the survey on the chat. So please go there once the workshop of today is finished. And I think with Nikos' presentation, we have completed the sessions for today. I'll give the floor to Apostolis. If you can come on camera, and if you want to say a couple of words and concluding remarks. So Apostolis, I'll give you the floor.
Thank you, Samuela. Thank you also Nikos that gave us a context, presented the context that we adopted in PrimeWater in order to try to work together with stakeholders in quantifying those very critical, let's say, decision-making attributes against or towards Earth observation-based technologies. This is a very important exercise. It's a very important exercise we're running in PrimeWater. Your participation in that is very, very important for us to receive and let's say analyze. We will come back soon with results out of this analysis that we expect to be very interesting. But well, closing up this session, let me just pick up a few points, also very interesting points that also have been raised by our, let's say, invited speakers, and say that observations are becoming a very powerful, let's say, technology that can provide good and robust solutions to many water resources management problems that we're facing around the globe. It comes with significant capacities and possibilities. There's still research is taking place in this field and unleash all the time new possibilities around this very, very powerful technology. It was all the presentations were very, very revealing and interesting, demonstrated how observations are applied already in different places along the globe. Our showcases in PrimeWater also aim to exactly to showcase how these how observations can be used, how observations can add value in everyday operations of water professionals in different for different reasons. But at the end of the day, what is really important, and I really impressed by the way that the SDG mission, NASA is working with stakeholders. It is important that all these new advances, all these state-of-the-art technologies that are generated to actually meet the purpose of the needs of the actual users. And this is a big, let's say, challenge nowadays. It's not just about the science, but also to find ways to connect the science with the actual everyday necessities of water professionals. And this is where we at PrimeWater working and aspire to work together with stakeholders around the globe, stakeholders from different water sectors, for this particular region, to identify those areas where these technologies can actually play a key role, to be more close to what to the expectations of the end users that they're having. So PrimeWater initiated from the beginning a discussion with stakeholders. This discussion is open. We hope that this discussion will still remain open. IWA has also provided a more structured platform for this discussion by putting together a working group that will actually focus on this target, on this topic, on how to make these technologies work better and closer to the expectations of the water industry. So that's mostly what I wanted to stress out, how important it is to establish this communication with the actual, let's say, needs. That is very, very important also for our group to provide even more robust services at the end of the day. That's for me, Samuela. Thank you so much for organizing this very beautiful day. Thanks. I think I would like to thank all the speakers that gave us their insights from using these technology, and would like also to thank all the participants that joined this session. I hope everybody found interest in these in today's workshop. Thank you so much.
Thank you, Apostolis. And again, I echo you saying thank you all. participants, moderator, and speakers to be up for being with us today. I have put in the chat before you go the links to register for the following meetings during this week. Once again, we will have meetings all over the week until Friday. Tomorrow's session starts at the same time and is about disaster risk management. And we will have also in that case speakers presentation and then moderated discussion. And then we will use a collaborative tool to discuss about the topic of the day. And I also put the link on the about the Earth observation technologies for water management community of practice, so you can learn more about that. And we will follow up with you with the presentations, the recording of the sessions, and all these links. So you will have all in one email. And once again, thank you so much for being with us, and we hope to see you again tomorrow and over the next days. Bye.